Now that we've spent some effort understanding exponential functions, we're going to now look into their inverses, which are called logarithms. So the first thing we're going to do is analyze the graph of exponential functions to see if they have inverse functions. Once we figure out they do, we'll define logarithms, and then we'll do some computations. So let's look at a particular exponential function, f of x equals 2 to the x. So here's what the graph looks like. Not the prettiest graph of 2 to the x that you'll find, but it's the best one I could do on short notice. Question is, what happens when you draw a horizontal line? And this is important because if we want to find out if a function has an inverse, it's got to pass the horizontal line test. So we want to see what happens when we draw a horizontal line. So I'm going to go ahead and draw a blue horizontal line there. And if you notice, that blue horizontal line hits the graph exactly once. And it doesn't matter where we draw that blue horizontal line. We can draw it way up there or way down there. It's always going to hit the graph at most once. And since every horizontal line hits the graph at most once, that tells us that f of x equals 2 to the x has an inverse function by the horizontal line test. Let's see if we can find it. So the way we would do it back in the old days is we would set y equals 2 to the x and then try solving for x. Except here we kind of get stuck. We can't solve for x in a reasonable way. So what do? So our conundrum is, we know that the function has an inverse, but we can't find a nice formula for it. What do? Well, first thing we're going to do is we're going to give it a new name. We know it exists, so we might we're not. It's not like we're naming nothing. We're going to call it f inverse of x equals log base 2 of x. And there's a good reason why we call it this. The log just indicates that's the name we give an inverse of a function. The logarithm is the name, the arbitrary name we give it an inverse of an exponential function. And the 2, that is the subscript there, tells us that we have a lot of exponential functions that we can choose from that we can find this inverse. The specific one it's coming from is f of x equals 2 to the x. So for instance, if we wanted log base 3 of x, that would come from the exponential function f of x equals 3 to the x. All right, so in general, if we let a be greater than 0, where a is not equal to 1, and if we let f of x equals a to the x, that one is going to pass the horizontal line test. You can see the different examples that we had for graphs of exponential functions to verify that yourself. It's going to pass the horizontal line test. That means it has an inverse, and since it has an inverse, if f of x equals a to the x, the inverse function we're going to call log base a of x. Now, again, you may be a little bit upset that we don't have a nice formula for log base a of x. So what's the point of even defining this thing? Well, even though we don't have a nice formula for log base a of x, we still know quite a bit about it. We know all the things we know about inverse functions. So for instance, any inverse function, f inverse of f of x equals x, is always going to be true. If we apply this specifically to f inverse being log base a and f of x equal a to the x, then what that means is that log base a of a to the x is equal to x. So this is something that we know about the log base a function. And of course, that works the other way around too. Remember, our f is our a to the x function, our f inverse is our log base a function, and so we get a to the log base a of x equals x. So these are two equations that we know are true just by virtue of the fact that we know that log base a and a to the x are inverses of each other. And if we have equations like y equals f of x, that gives us x equals f inverse of y. We can apply that to our functions as well. If we have y equals a to the x, that means x equals log base a of y, which we can use for all sorts of computations, and we can also use when we want to graph the log base a functions and see what the graphs look like. And if we want to flip that around, if we have y equals f inverse of x, that means x equals f of y. So if y equals log base a of x, that means x equals a to the y. So again, some nice equations that we're able to deal with just by knowing that they're inverse functions of one another. And we're actually going to use this to do a computation. So suppose we want to find out log base 4 of 256. Our general approach for logarithms is, I don't understand logarithms, right? So that's where I start. And maybe that's not literally true, but let's, we're sort of play acting. We're having a little drama here. I don't understand logarithms, but I do understand exponential functions. So if I want to try to understand logarithms, I don't want to do it through them directly. I want to do them through the exponential functions, which I understand a lot better. So remember, we're looking at log base 4, so that's the inverse of f of x equals 4 to the x. So if f of x is 4 to the x, that means our f inverse is going to be log base 4 of x. And so we can do all the goofy things that we did with inverse functions to 4 to the x and log base 4 of x. Which means that if y is equal to log base 4 of x, which is close to what we're looking for, that means that x is equal 4 to the y. Now, of course, we want to do that in the case where x is equal to 256. So why do we do that? Y is equal to log base 4 of 256 means that 256 equals 4 to the y. And so now all we're looking for is a value of y, where if we take 4 to the y, we end up with 256. So let's give it a try. Let's try out some values of y, see if they work. So if I try y equals 1, I don't know, 4 to the 1, that equals 4, not 256. Y equals 2, 4 to the 2 equals 16, closer but still not 256. Y equals 3, 4 to the 3, that gives us 64, still not there, but notice that when we get to y equals 4, 4 to the 4 is equal to 256, and so y equals 4 is exactly what we're looking for. So if y4 equals 4, remember, our y was equal to log base 4 of 256. Since also our y is equal to 4, that tells us that log base 4 of 256 is equal to 4. So this gets you sort of a head start looking at how to do these types of computations. Now you're going to get some more practice on the PDF included with this video. It's called Introduction to Logarithms.